All right, guys, welcome back. Continuing on with our Math 31 and 31 AP derivative lessons. And next topic is what we call the chain rule. All right, guys, so this is my favorite metaphor to kind of explain what's happening in what the chain rule is about. Okay. Now, what I want to do is over here is I want to picture two paper boys. Okay. First paper boy is this guy over here, and second paper boy is the guy on the bike over here. Okay. Now, the paper boy is standing in front of a house, and he throws the paper towards the front step of this people's house. He misses the front door, and he hits a window. Okay, now what happens is the window does not break. The paper hits the window and just bounces off. Okay, now the second paper boy, okay, he's now riding on his bike towards the same house, and he throws the paper at the front step, and again, he misses too. But when he misses, it hits the window. He shatters the window over here instead. Okay, so the question becomes, well, why did the second paper boy break the window but not the first paper boy? Okay, and the reason is we have to think just a bit about physics over here. And for the first paper boy, the only force that's being applied to the paper is his arm. Okay, so he's throwing it like that, so it's kind of the strength of his arm is kind of throwing the paper at the window. But then the second paper boy, there are now two forces being applied on the paper. Okay, there's his arm, which is throwing it, but also the bike is moving his body, and so it's the bike moving is applying a force on the paper, but then also his arm is as well. Okay, so the chain rule is a very similar type of idea. Okay, now instead of like the force being the speed or the force of the paper being thrown. Okay, well in calculus it's the rate of change of y over x because a derivative is going to be a function which gives you the slope of the tangent. It's a rate of change. So when we look at this example over here, we have y equals 3x plus 2 cubed. Okay, now I want to kind of take this example back to the paperboy example. On the paperboy on the bike, there's two forces being applied to the paper. There's the bike and his arm. Okay. Well, in this function over here, on the inside part, we have a linear function. Okay. And this guy has a rate of change, so we can calculate the derivative of the linear function. But then it's something cubed. Okay. So think of this as the something cubed is like the bike applying a force to the paper, and the 3x plus 2 is like the arm applying a force to the paper as well. Okay, so in this case, when we're talking about our derivative, which is going to be a rate of change, which gives the slope of a tangent, well, we have a linear function and a cubic function being applied to that one. So here's how we do it. The first thing I'm going to do is I'm going to take the derivative of the cubic function part. So that means the 3 comes down in front, okay, and then it becomes 3x plus 2 squared. Okay, so this is the derivative of the cubic part, okay? But we also have the linear function, which is 3x plus 2. Well, the derivative of the linear function is just 3, okay? So this part over here is going to be the derivative of the cubic part. And then this part over here, this 3, is the derivative of the linear part. Okay, so this is how we do this. Let's go on to the next page. So the chain rule, if you guys remember, guys, back to our Math 30 course, we had a unit called operations of functions, and one of those topics was called composition of functions. So this is really what this is over here. We have f composed of g of x, so f is the outside function, g of x is the inside function over here. Okay. Now, what we have over here, y prime is f prime of g of x. So in other words, what we're doing is we're taking the derivative of this part over here, the f, and becomes f prime, and then the inside part stays the same, like we did over here, right? So this guy over here was like something cubed. The 3x plus 2 for the moment stayed the same, and just the 3 came down in front, and we took one less on the exponents. We're using our power rule for the cubic part. But then at the end, we take the derivative of the inside part. Okay, here's how I remember this one. The chain rule is the derivative of the outside times the derivative of the inside. And that's what the chain rule is. Okay? All right. So just applying the same question over here to this function over here, we have something cubed, and there's something on the inside. So the inside function is x cubed minus 5x squared plus 2x plus 6. The outside function is this whole thing cubed. So our derivative is going to be, we're going to take the derivative of the outside. That means the 3 comes down. Everything on the inside stays the same. Okay, and now we take the derivative of the inside. Done. Okay, so this is all we're doing for a question like this. Derivative of the outside. You guys, you don't need to write this down every time. I'm just trying to, that's this part here. And this part here is the derivative of the inside. Okay. Here's where it starts to get more difficult. Now, if you guys remember, guys, when we did the product rule lesson, I said that the purpose of the product rule lesson was to teach you how to use the product rule so that when questions got more difficult, like this one, we know what to do. Okay, so this is a question where like expanding 2x minus 5 to the 5th and 3x minus 4 to the 7th, and then collecting all your like terms after that would be a nightmare. It would be way too long, and like, I mean, you'd probably make a mistake, or I know that I would probably make a mistake while I was doing it. Okay, so we have to use, so this is like this function times this function over here. So we have to use our product rule for this guy. So product rule again was first second prime plus second first prime. Okay, so when I'm doing this guy over here, I go first 2x minus 5 to the 5th, second prime, all right, now here what the second prime is. Okay, so when I'm taking the derivative of this guy, the 7 comes down and becomes 3x minus 4 to the 6th, but then I still need to take the derivative of the inside and have this 3 here, plus second first prime. So I have 3x minus 4 to the 7th, that's my second function. First prime, the 5 comes down, 2x minus 5 to the 4th, and now the derivative of the inside, the derivative of 2x minus 5 is 2. Okay. All right, so this is quite a long expression over here, and here's how we're going to simplify it. Okay, we're going to simplify this by factoring here. Okay, we have 3x minus 4 to the 6th and 3x minus 4 to the 7th. So between these two terms, we have 3x minus 4 to the 6th is common between them. So this is going to be 3x minus 4 to the 6th. Now, okay. Now, also, I have 2x minus 5 to the 5th, and then 2x minus 5 to the 4th. Between the two terms, 2x minus 5 to the 4th is common. So 2x minus 5 to the 4th. What do we have left? We have 7 times 3 is 21. 3x minus 4 to the 6th is gone from this one, and I took out 4 2x minus 5s, but that means there's 1 left over, 2x minus 5 here. I took out, so I have 5 times 2, which is 10. I took out 6 3x minus 4, so that means there's 1 remaining here. And I took out 2x minus 5 to the 4th here, so this guy's gone. Okay, so we have 3x minus 4 to the 6th, 2x minus 5 to the 4th, and multiply this through. 42x minus 105 plus 30x minus 40 42 plus 30 is 72x. Negative 105 minus 40 minus 145. Okay. And guys, this is how we're going to leave this question like this. Okay. So we're going to leave this question in this, we call this like the fully factored form over here. And we're done. Okay. Similar type of question over here. On the inside, we have a quotient. On the outside, we have something cubed. Okay, so we have an outside function is something cubed. The inside function is x minus 4 over 3x minus 2. So our derivative, we go derivative of the outside is 3 like this. Okay, so there's the derivative of the outside, that's the cubic part, times derivative of the inside. Now, derivative of the inside, we have to use quotient rule. Bottom top prime minus top bottom prime over bottom squared. Okay, so we get 3 This is what I did here, guys. I just went like negative 3 times x, negative 3x, negative 3 times negative 4 is positive 12 over 3x minus 2 squared equals 3 x minus 4 over 3x minus 2 squared. 3x minus 3x disappears. Negative 2 plus 12 is 10 over 3x minus 2 squared. Now, just what I'm doing here next, the way I would simplify this is I have a 3x minus 2 squared here and a 3x minus 2 squared here. So I can multiply those guys together. It's going to give me 3 x minus 4 squared, 3x minus 2 squared, times 10 squared, which is 100, over 3x minus 2 squared, equals 300 x minus 4 squared over 3x minus 2 to the fourth. And here's our derivative for this guy over here. Okay. So guys, I mean, we're starting to get into the thing like where the algebra starts getting pretty intense on some of these questions like that, but this is how this one works over here. Okay. So please, guys, keep up with your homework practice, guys, and come and see me if you have any questions. All right.